We're going to talk about the electron today. You thought the proton was a pretty big problem in quantum mechanics. Forget about that. The electron is really the darting quantum mechanics. Okay, together with a photon. Photon and electron are more or less both in there. Anyways, in order to get to the subject matter, let me start with some introductory quotes by the founders of quantum mechanics. Here's the first one. His name was Niels Bohr. What does he have to say about quantum mechanics? Well, he said the following. He says, there is only an abstract quantum physical description. Abstract description. That's all they have. That's all that quantum is. There's no explanation, no mechanisms, no causes. It's an abstract description, and it's a mathematical description. It is wrong to think that the task of physics is to find out how nature is. Physics, meaning mathematical physics, meaning mathemagics, right, concerns what we can say about nature. That's all they're talking about. That's all they can do. Everything we call real is made of things that cannot be regarded as real. Nothing exists until it is measured. Now, are those some prophetic words or what? Yeah, and one of the big problems of quantum mechanics, of all of mathematical physics, is that they never define what a thing is. They never define what an object is, what a medium is, what a body is. They never have a word, you know, you don't have a single textbook of physics on the planet that begins by defining what an object is, what a thing is. You would think that, you know, that's the first word that should be in every textbook on the planet, physics textbook, right? Because what you have is you can't do physics without an object. You need a thing that's got to be moving. If you don't have a thing and you only have motion, what's moving? A spirit? You know, and this is the issue. They have all these concepts that are moving. The field, energy, mass, charge. Those are not physical entities. Those are quantities, right? So we have a problem because there are no physical objects in quantum mechanics. Here's another fellow, a buddy of Niels Bohr. His name was Werner Heisenberg. Okay, and he said the following. He said, the natural laws of quantum theory no longer deal with the elementary particles themselves. Quantum mechanics has led physics, or physicists, right, far away from the simplistic materialistic views that prevailed in the natural sciences of the 19th century. Primarily the issue of the ether, right? That's what they got rid of, or they thought they did. The most important step was to see that our language is not sufficient to describe the situation. In such a world as the path of the electron, they are quite understandable when you have to do with stones. But when applied to electrons, they really don't mean much. The difference between elementary and composite particles has disappeared. Okay? So like a proton and made out of quarks, that's what he's referring to, even though he wasn't from the day. Well, he kind of was in the days of quarks, right? He died in 76. He said, no unambiguous answer could be given any longer to the question about what these particles consisted of, since this question no longer has a rational meaning in mathematics, in mathematical physics, right? And that is no doubt the most important experimental discovery of the last 50 years. In other words, yeah, he was probably talking around the time of his death, because 50 years, you're talking about 1926, 1925, thereabouts, when quantum really took off. That's when they started doing all the math, Schrodinger's equation, the Born cloud, etc. And this is what Max Born had to say about that. A little later, I think it was 1962, 68, thereabouts, and he said the following. He said, since the development of special relativity, theories using a substantial ether fell out of use in modern physics and were replaced by more abstract model. The problem is that, you know, what Born had to say is that abstract is the opposite of physical. Okay, and so we should call them abstracists, not physicists. Okay, and he said, I am now convinced that theoretical physics is actually philosophy. Okay, so these people don't do physics, they do philosophy. They just come up with whatever explanation comes at the top of their head, And it's always irrational. It's always an irrational explanation, meaning you cannot picture it. You cannot imagine what they're saying. And they cannot put it on the screen because whatever they put on the screen doesn't match what they're saying. You know, what are you going to put for field? What are you going to put for energy? What are you going to put for mass? What are you going to put for charge? Number? Is that what you're going to put on the screen? Represent it with a little ball? Is that the way it works? You know, so this is the problem. They're doing philosophy. And last guy I'm going to quote here, his name is Richard Feynman. He said, I think I can safely say that nobody understands quantum mechanics. And he says that the more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics, mathematics, has given up on that. And he said two things there that you got to keep in mind. When he says they've given up on that, meaning it used to be part of physics, okay, but they gave up on that. They said we can't explain anything. That's one issue. The other issue is they cannot explain it. So to this day we have no explanations. And yes, it used to be part of physics, but they've given up on that. They don't do that anymore. They just do math. They call it physics. They continue calling it physics. That's the status today. And so what's the problem there? Primarily is that they don't have an object in front of you. They're not doing physics at all. They're not simulating their mechanism with a real physical object. I don't care if they use an analogy. An analogy is okay, but the analogy has to stand for something. You know, you can't represent space-time, a concept, with a physical object. You cannot represent a number, such as energy, which is a number, a quantity. You cannot explain field, which is a bunch of numbers, right? You cannot represent that with a physical object. You cannot put a thing there on the screen and say, this is a field, or this is energy, or this is mass. You cannot do that, because those are concepts. It's like saying you're going to represent love with a heart, again, you know? And yeah, it's an irrational thing. You cannot, not in physics, you cannot put a heart and say this represents love. That's not an analogy, okay? You can say a fishnet represents something, like, you know, a canvas. So if you're going to talk about a canvas being weighed down, like in the case of relativity, you can represent that with a fishnet. But they don't have what they're representing is 4 number lines. You know, that's those lines that you see there, those are number lines. And they're bending the number lines. They say, well, you understand the mechanism there. We're weighing down the number lines. We call that a canvas, a fishnet, whatever, a trampoline. What is that? And one fellow, a visitor to the site here, he synthesized it quite well, and I liked what he had to say, so I'm going to reproduce almost everything he said. He said, the word physics is only relevant to the classical world in any sense of... The word physics is only relevant to the classical world in any sense of a physical object. But even then, the concept of anything that we call physical is really on shaky ground. So no, we don't appear to have anything in the universe that is represented by the classical concept of something physical. There is nothing physical as far as discrete object is concerned. And he's saying exactly what, you know, the way it is in mathematical physics. There are no physical objects. All there are is abstract concept, mathematical concepts, which they represent with physical objects. He says, in an invisible but measurable, is an invisible but measurable force physical? Is the magnetic field physical? Well, hopefully it is physical. Here you have 2 magnets that I always show, right? And you say, well, there's a force there. Yeah. And why is he saying that there's nothing there, there's nothing physical? Well, because he can't see or touch them. He says there's nothing here. Yes, there is something here. The problem is you can't see or touch it. That's the problem. A field is mediated by something, and that's something that they had to discover all these years. That's what they never did. And so he says, this is the closest there is in the universe that is representative of the word physical. It is just a force in an empty void. Absolutely not. Force, field, energy, all those are mediated by physical objects. Otherwise, you are doing black magic. You're doing action at a distance, which is the scientific version or term for black magic, witchcraft. That's what you're doing. So you better put a physical object in there, and you better not define the word object as that which you can see or touch. Not all objects can be seen or touched. Among them, the most important example, air. Made out of atoms. Hopefully there's something there. You feel it, you know, something's going through your nose, but you can't see it. So because you can't see it, there's nothing there. It's a spirit that goes through your nose. So this is the problem. Yeah, there is something there, but you can't see it. Okay? And you can't touch the table that's on the other side of the universe. So hopefully the table is always a table everywhere. Okay, and here you have same fellow. He says, he goes into the word energy, which is what he thinks everything is made out of. He says, our classical brain has trouble with that concept of the absence of any truly solid object or solid anything. The only reason we don't fall through the floor is because of the non-material forces that resist it from happening. It's all just empty space or a void. So he really thinks he's going to do physics with nothing. He thinks the reason you don't fall through is there's nothing there holding you up. He really believes this, because that's what quantum mechanics has told him, that everything's just empty space or just forces or energy. And he accepts that those are concepts, so that you can't picture any physical object. So he says there's no physical object underlying any phenomena. That's his conclusion. And that is the conclusion. That's the way mathematical physics operates today. So he said matter is just another representation of energy, a non-material force. Now energy hopefully has something physical in it. Energy is the concept, is the mathematical description of that thing. But you have to identify the thing which is invisible and intangible, called energy, or that underlies energy, the concept of energy. So everything that there is in the universe is energy. Non-material in the classical sense, and forces like the field of a magnet, also non-material. So they're doing everything with spirits, with angels, with all these ghosts. There is no true physical universe. In truth, that would mean physics, study of physics, is an incorrect term for this study of how our universe works. There I agree with him. You can't call that physics. That is not physics. And just in case, we have good old Richard Feynman again. He says, it is important to realize that in physics today, mathematical physics, we have no knowledge of what energy is. And the problem with what Feynman says is that, energy is a concept. So he was talking about a what. Now you can't say what is energy. That's an irrational statement. Okay, because energy is not a what, not a thing. Only things are whats. Okay, so this is the problem. Energy, the capacity, the ability, and those are concepts. Concepts we define, objects we point to and name. Okay, so if you want to present an object in physics, you point, say table. You point, you say rock, tree, and so on. That's the way it works. And people see the object, understand the noun, understand what that word refers to. That's the way you present objects in physics. What are you going to point to for energy? A cloud of smoke? And that's how they represent it, as a cloud of smoke. No, what has happened is mathematical physics is really all math. It's gone completely into the math world for the last 100 years, and that's why they cannot explain anything. Partly because it's all math, and partly because they're representing all these mathematical concepts with physical objects, moving the object, and you're thinking, oh, they're moving the field, oh, they're moving the mass, oh, they're moving the force. And what you're really, you're staring at an object, but that object is representing a concept. That's the problem. Like the soul, what do we represent the soul with? We represent it with a spirit, right? So you draw a ghost, you draw an angel, and you move the angel and say, okay, I understand that, the soul moved. No, an angel probably moved, not the soul. Soul cannot move, conscience cannot move, mind cannot move. Okay, it's a concept. People don't always pick up on that. And yeah, so they went in the mathematical direction, and one fellow, his name is Max Tegmark, he said the following. He says, mathematical universe hypothesis. He invented this notion. He says, the MUH, mathematical universe hypothesis, posits that the fundamental nature of reality is mathematical. So he says math is the reality, okay? Meaning the universe is a giant mathematical object. Object? Maybe a mathematical concept, but never a mathematical object. What is a mathematical object? If the MUH is true, the properties of the universe would stem from the relationships between its fundamental building blocks rather than the inherent properties of those blocks themselves. In other words, he's not talking about things, he's talking about relations, okay? In other words, they compare things, they contrast things, or show them moving or whatever, one thing with respect to another, and it's those relations which they mathematize, and that's what they call physics. And so far we have no objects in front of us because they can represent all of that with point particles or points, right? And they say that's a particle. And no, that's not a particle. And I like to say that, you know, when you have an elephant, you can find out what the center of mass of that elephant is. So you have, I don't know, an elephant weighs 5 tons. You put it into a point, you say, okay, that's the center of mass of this elephant, right, of these 5 tons. No problem so far. The problem when you start moving the point, that's when they commit their irrationality. You can't move the point. The point is there, that's the center of mass. You don't move the center of mass. What you move is elephants. You got to put the elephant back in if you want to move something. And that's where they get the irrationality. You start moving points and they say, I'm moving the elephant. No, you're not moving an elephant, you're moving a point. You're moving the center of mass. And that's irrational. That's okay in math because all you're interested in is in the motion, but the fact that you put a point to represent the elephant does not allow you to move the point. You have to move the elephant. Okay, and that the MUH can be seen as a form of Platonism, where abstract ideas like mathematical structures, whatever that is, have a real existence beyond our minds. Existence is not something you measure, and it's not something that's beyond the mind. Existence we define, and it's an object that has location. So you have to have an object. There are no such things as mathematical objects and no such things that as mathematical objects that exist. You cannot say that a mathematical object exists. First you would have to define it as a thing, meaning it has to have shape. Then you can say, you know, you can hypothesize that it exists. Okay, so where did good old Max Tegmark get all this stuff from? This thing about a mathematical universe. Well, he probably got it from this guy. His name was Galileo, and he said the following. He says, philosophy, nature, is written in the great book whichever is before our eyes. I mean the universe. But we cannot understand it if we do not first learn the language and grasp the symbols in which it is written. The book is written in mathematical language. Mathematics is the language in which the God has written the universe. He gets it from one of his books. And where did he get that? Well, he got it probably from this guy. His name is Pythagoras, who said more or less the same thing 2,000 years before him. He says, mathematics is the language of the universe. Reality is fundamentally mathematical. This is what all these mathematicians have been doing for the last 3,000 years. Numbers are building blocks of everything. No, not in physics. Objects are the building blocks, or atoms you could say, but not concepts, not mathematical concepts. Mathematics is not just a human invention, but the language used by the universe to describe itself. No, Father Universe never went to school. Mother Nature never went to school. They don't know what mathematics is. All they do every single day of the year, every single second, is move one atom from one location to another. They deal with objects. They're known as atoms, and they move them from one place to another. That's it. That's all they do. And do they make relations between atoms, between things, objects, stars and moons and planets and so on, galaxies? Absolutely not. They don't make any relation whatsoever because every atom in the universe has only location in one frame of the universal movie. In the next frame, they all are those same atoms, right? They all have location again. That's all they have, location. And in the next frame, all they have is location. So any frame that you analyze, that you look at, only has every atom in the universe at a given location. There's no relations, no mathematics, none of that. Father Universe does not understand math. But this is what these people came up with. And he said Copernicus, well, not him, but other people say Copernicus, Kepler, Galileo, and Newton developed a scientific understanding of the universe based on mathematical principles. Yeah, so all they had is a description. They never had an explanation for anything. Not one of those individuals ever understood how this universe works because they had it wrong from the start. They thought mathematics was going to give them an insight into what gravity is or what light is, and it never did. And to this day, not a single mathematician on planet Earth, from Cambridge, from Harvard, from the Ivy League or whatever, none of those people can tell you what is out there and what the mechanisms are that underlie phenomena such as gravity and light. Okay, so here we have the AI, and it says more or less the same thing. It summarizes this thus: modern physicists continue to explore the idea that the universe is ultimately mathematical. That's where the problem is. They continue looking for math when math is the wrong tool to analyze the universe. It has nothing to do with what is math. Math has nothing to do with it. With theories like string theory and the mathematical universe hypothesis drawing on what? Pythagorean ideas. Yeah, this is what they came up with. They think they're going to figure out what the universe is, what's out there, what exists, and the mechanisms of the universe. They think they're going to resolve it through mathematics, when mathematics is the wrong tool to apply to the question we're asking. We want to know why, this falls to the ground. Why do I need to know any math? Why do I need to study any, or, understand any equation? Why do I have to invoke numbers to explain the mechanism of what causes this to fall to the ground? That's gravity. That's the only experiment we ever needed. And yes, hopefully, whatever is here or here, pushing or pulling, is invisible and intangible, and there had better be something here. Otherwise, you're introducing angels. You're introducing action at a distance. You're invoking black magic, voodoo physics. You're saying that from the far you can move things around. Telekinesis. Absolute nonsense. None of that happens in physics. Only in the minds of religious people who are spiritualists, and they believe that things happen only because, they happen. And then just, I don't see anything there. So the reason the spoon fell to the floor was that, there's some kind of spirit. Or they describe it and say, well, this is how fast it fell. Yeah, that doesn't tell me what caused it to fall. And that's where we're at today. We have no explanations for those phenomena. Here we have good old Neil Tyson. He's going to tell us something which he likes to say constantly, and he says the following. Listen to him.
The universe is under no obligation to make sense to you. What that means is your 5 traditional senses. They're not as good at contemplating infinity. You can't intuit infinitesimal. They're things that are impossible for us.
So he says the universe has no obligation, Father Universe, right? He has no obligation to make sense to us. Okay, and here he says it again, just in case, he likes to say this in every show that he's in. He thinks he's very smart for saying this, right? Here he goes again.
The universe is under no obligation to make sense to us. It's the observations that matter, even if they conflict what feels right to you.
Okay, so what is he saying? He's saying the universe, Father Universe, doesn't have to make any sense to us. What is he saying? He's saying that the mathematicians are the representatives of Father Universe, because Father Universe only speaks in mathematical language. And so they are the priests who interpret the universe for us, right? They study all this math through 10 years or whatever, and so they say, well, we represent Father Universe, and Father Universe doesn't have to make sense to you, meaning that the mathematician doesn't have to make sense to you. Okay? So they're saying they're appointing themselves as the priests that represent God, the God of universe, universal God, and they say we represent him because he speaks our language. He's the mathematical language. And so if you want to understand Father Universe, you got to go through us. And we explain it to you, we give it to you, all these mathematical descriptions as best as we can. And if you don't understand us, well, it's because you're not understanding Father Universe, because he doesn't have to make sense to you. That's the way they put it. No, this is very simple. I don't care about Father Universe or about your God, okay? You, the presenter, has to make sense to me. If you don't make sense to me, you're an irrational individual. Okay? In other words, if you can't make sense of what you say, you're an irrational individual. And of course, if you cannot put your theory in on the board, with pictures and illustrate your mechanisms, your causes, then you're an irrational individual. You don't have a theory to present. But they say, look, we can describe what Father Universe does. We represent him because he talks only in the language of mathematics. No, he doesn't. Father Universe never went to school. He doesn't know anything about math. He moves atoms from one place to another in every frame of the universal film. And what these people have to do is explain the mechanisms. If they cannot explain the mechanism, they don't have a theory. Description, a mathematical description, is not a theory. Period. We're done. These people call what they do theories. They don't do theory. The theory part is the explanation, and those are all irrational. So none of those are valid in science. So they don't have a theory. Quantum is not a theory. Quantum is a statistical description of what they think is in there, based on the assumption that what they think is in there are particles, discrete particles, which ain't particles either, because they acknowledge that those are not corpuscles. They're not little grains of sand. What they're staring at, or they think they're staring at, when they go to the lab, is all these values. They think they're looking at particle, a little discrete particle. At least that's how they represent them. But of course, they cannot make sense of that. They cannot make sense of what they think is in there, because they don't see it. It's not like they see it. It's like they assume that what they're staring at are a bunch of particles. And so they just mathematize it. They talk about energy, mass, charge, force, field. And they say, look, the field moved this way, vibrated, here's the particle, which ain't a particle, here's a force, which ain't a thing, right? Mass, it ain't a thing. Energy, it ain't a thing. None of those are things, but that's what they introduce as things into physics, into mathematical physics, or into the scientific environment. And that's where we get lost. That's where we have irrationality. So the only thing coming out of mathematical physics is irrationality. They're using the wrong tool, which is math, to explain their theories, if you can call those explanations or theories. And that's what people believe, and they just regurgitate what these people are saying. And that's the world we have today. That's the state of the art of mathematical physics. And in relation to quantum mechanics specifically, because they can't see or touch any of the things that they have in there. So they think they're colliding particles, and you say, you mean two particles collided? Well, a particle is just a number, just an energy, which we call mass, because according to Einstein's equation, energy and mass are the same thing. And so they're colliding energies, they're colliding masses, kilograms or electron volts or whatever they're colliding in there. And they say we collided particles. And people say, okay, the two little balls hit each other. No, that's not what they did. They accelerated whatever they accelerated at a certain energy. They collided these things, whatever it was that collided, and then they represent all that with mathematical concepts. And that's why we have a big problem, because we don't have physical entities in front of us. There are no physical entities in all of mathematical physics.